Okay, on this second page we have 3 more problems that we have to be prepared for the second quiz in this chapter. The first one is another parallel lines problem. So this one is almost identical to one of the problems on the first side, except we don't see a full triangle. We have our 3 parallel lines here. We have 2 transversals. There's 2 things involved. First, segment addition. I know that this entire segment, if I called that A and that B, then segment AB is 44. And if I called that AC is 18. So segment addition, I subtract 44 minus 18, I get 26. CB is 26. Now it's a matter of setting up my proportions. Again, I like to do this. There's 2 ways to do it. I like to do it between my parallel lines, set up my ratios, set up my fractions here. X plus 3 over 18 equals 2x plus 1 over 26. Again, if I start with x plus 3, I have to put 2x plus 1 in the numerator on my other ratio, and my other fraction. And along the same transversal, they have to be in the same location in my ratios. Now, the rest of this is cross-multiplying. I have 18 times 2x plus 1 equals 26 times x plus 3. Make sure you're distributing. Giving you a second here to pause and do the algebra. We should get x equals 6. In number 5, the key is our overlapping triangles, and we have to be able to name our similar triangles if we want to be able to appropriately solve for x or solve for y or both, whatever the case may be. So remember, I like to do this by numbering these 2 big angles. If I number that angle 1 and angle 2, that's going to help me in naming my similar triangles here. So I'm just going to do this way. I'm taking the big triangle and drawing it out separately. That's the one that we have already named, triangle ABC, and if we go by the angles, we have angle A is angle 1, B is my right angle, and then C is my angle 2. So now every triangle I need to name with those congruent angles. Now the last thing is label the only side length I know here. I don't know AB or BC. I do know that AC, and again, that's going to be a segment addition. I know that whole thing is x plus 4, so I can come over here and label this x plus 4. Now, we want to separate out our other triangles, and before I do that, I want to point out, if this is a right angle, angle addition, okay, that's a linear pair. This is also a right angle. So, if I draw out this small triangle here separately, I forgot to draw some of it. Let's fix that. So let's try that again. Now I have my next triangle, and again, the one thing I didn't do was, this was angle 1, that's here, angle 2 is down here, it's not in this triangle. But I do know that I can name that, because I need to name it with angle 1 first, and my right angle second, and my angle 2 third. Well, angle 1 is again A, but this time my right angle is D, and that means B must be my angle 2. And lastly, I have my third triangle. Remember, that was my angle 1, this is my angle 2. So when I draw this or look at this triangle separated out, it looks like this. I have my 8, my 4, here's my angle 2. So again, if I want to name in the same order, angle 1, right angle, angle 2, the ones I have labeled for sure are my right angle, that's D, that goes in the middle. Angle 2 is C, which means B in this case corresponds to my angle 1. Once I have my similarity statements here, the rest becomes identifying how to set up a ratio to solve for x. The easiest one to use here is AD, so now I'm definitely using this second triangle because I want to use segment AD. in my ratio. Okay, so I'm using triangle ADB, and I'm going to use it and compare it with, well, I know two pieces of information in this triangle, only one here. So in reality, I can't use this triangle. I have to use this triangle. And that's triangle BDC. Make sure you name it correct. I'll make sure I write it correct. Now, I know AD is X, and AD, which is first and second, corresponds to BD here. The other side length I know is DB here, and DB is second and third. It corresponds to DC. So now I can set up my actual proportions to solve. AD is X, the second triangle BD is 8, and that equals DB, which is 8, over DC, which is 4. Cross multiply, we find that X is 16. Just to reiterate, the key is drawing these out separate, identifying your corresponding angles to set up your similarity statement. That's going to be the key to all of this. That's how you set up your proportions and solve. Our last problem is a coordinate problem. Wants you to start by plotting the original triangle, triangle ABC. Pay close attention, make sure you're plotting these points accurately. If you have to, go back and double check that. Now it's asking us to dilate with a scale factor of 1/3. That means I am going to multiply 1/3 times every coordinate. That will get me an A prime at -3, 3, multiply them by 1/3, a B prime at 1, 2, and my C prime stays at 0, 0. So I plot that and graph anything that's new. I don't have to plot C prime. If I want to just leave this point here and put C prime on here, that's fine, either way. Part B is asking us to find the slope of segment AB and then the slope of segment MN. AB, we're going 1, 2, 3 down. That's a -3 rise. And then a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 run. It's to the right, so it's positive. So it's -3 over 12. That simplifies to -1/4. And then the slope of MN, so I named him A prime, B prime. It did tell us up here a new triangle MNC, so I could have and should have labeled them M and N. So the slope of MN is down 1 and 1, 2, 3, 4 to the right. That's just down 1, right 4. This is our evidence that our slopes are identical, which is helpful because when it says, can you prove by angle-angle similarity that those two triangles are similar, explain using complete sentences, we've just shown mathematical evidence that segment AM is parallel to segment MN. And we can start by stating that. Segment AB parallel to segment MN, since they have the same slope. That's the first step. Now, angle-angle similarity means we have not one, but two pair of angles that are congruent. So I'm going to say, therefore, angle, and this is the key, figure out which angles are your angles and be able to name them accurately. That is just one angle up here. I can call that angle A. That's not a problem. It is congruent to angle, well, this angle is going to be congruent to this angle down here. I cannot call that angle M. There are multiple angle M's around here. So I'm going to have to use the three-letter system, okay, and call this angle NMC or angle CMN. and I need a second congruence, I'm going to go with angle B to angle here, but it's not angle N. You will lose points if you call it angle N. Angle B is congruent to angle MNC since they are corresponding angles of parallel lines. That's my angle-angle similarity. Angle, angle, similarity. That would be enough to gain full credit on a problem like this.